Sarasota. Hi everybody, welcome to 24 Hours of PAS Summer 2014 Preview Edition. Today's session is presented by Argenis Fernandez from SurveyMonkey, and his topic today will be how to secure your SQL Server instance without changing any code. A little bit about Argenis. He is a SQL Server MVP as well as an MCM. He is based in Redmond, Washington. He has worked with SQL Server for over 16 years and enjoys large SQL Server farms, high-end OLTP databases, and managing Windows environments. He loves performance troubleshooting, high availability, disaster recovery, best practice, and PowerShell scripting. Prior to SurveyMonkey, Argenis worked as a senior DBA for Coinstar Redbox and as a senior consultant on the SQL Server core team for Microsoft Consulting Services. In 2013, he founded the security virtual chapter for PAS. Argenis is a very active SQL community member and speaks very frequently at major SQL Server conferences, including PAS Summit, PAS SQL Rally, IT Dev Connection, SQL Bits, and Microsoft TechGit. Argenis is also a Microsoft Certified Master on SQL Server 2008. So, yeah, I hope you guys learned something and enjoy the session. If you require any technical assistance, please feel free to raise your hand, and yeah, I will try as best as possible to assist you. Let's see, we have one already. I'd also like to thank today's sponsors. It's brought to us by Microsoft and Dell Software. So please visit their sites. Feel free to visit their sites. If you plan to attend PAS Summit Start Saving today, it's the world's largest gathering of SQL Server BI professionals. There's over 190 technical sessions, and you'll definitely be learning something new. It's attended by over 5,000 people representing 2,000 companies and from 52 countries, ready to network and learn. If you plan on attending and haven't bought your ticket yet, please feel free to use the discount code 24HOP14 to save $200, and you'll only pay $1,895 until 26 September.
All right, I think at this point I am ready to get started. Jody, thank you very much for that warm introduction. I truly appreciate it. Good morning, good afternoon, good evening, everyone, wherever you are in the planet. There's 251 people plus those of us who are working behind the stage to make this presentation happen. 252 people now that are very security conscious, and I'm truly excited to see that big number there. Today we're going to talk about how to secure your SQL Server instance without changing any code. And by this means that we're going to discuss all the methods that you could possibly apply to your instance to further secure it or reduce its surface area without touching any of the code for any of the applications that are running inside of your SQL Server. So Jody already made a presentation about me. I'm just going to quickly breeze through this. SQL Server MVP. I work for SurveyMonkey. We're currently hiring. So if you're interested, go to www.surveymonkey.com. And then I'm going to move on right into it. Why do we bother? Why do we want to bother with security? Security is extremely hard. Security is hardly convenient. Well, this is why we want to bother. 160 million credit cards later, a cutting-edge hacking ring cracked. And this is news from last year, actually, from July 25th of 2013. More recently in the news, we have a huge breach into large the retail stores in the U.S. like Target and Home Depot. They were not SQL injection related, but this one was. This one was uncovered last year. Was indeed caused by SQL injection. And SQL injection is actually one of the biggest issues that we're going to talk about today. And, you know, right, perfect segue into my next slide. There it is, the biggest threat, SQL injection. Essentially, SQL injection works by you entering malformed data into form fields, or it could be anything really. It doesn't necessarily have to be form fields, but the general idea is that you're taking, little parameters that are being passed to the database, and you're changing those in such a way that you're making the code behind the scenes work for you, or for you in a bad and evil way. Now you can see from this example that I have on the screen here, you have a username and password field there for a very simple web login form. It's essentially issuing a select star from users where username equals this and password equals that. Now, granted, this is a very basic example. This is just for example's sakes. You would never do this. You would never compare an actual password to its clear form version. But the point of this slide is that you could tweak that particular query that's being built behind the scenes to do whatever you want. And in this case, you're replacing a regular username for a quote. We would essentially truncate the last string, and then an expression that would always evaluate to true. And now you would return everything for every single user there. So basically, one of the things that we want to talk about in this session is how do we mitigate SQL injection. Here's the agenda for today's talk. We're going to discuss the SA account, which is the omnipresent account in SQL servers. We're going to discuss a little bit about database firewalls. We're going to talk about Active Directory. We're going to discuss IPSec, Transparent Data Encryption, or TDE. We're going to talk a little bit about auditing. We're also going to mention contained database users or contained databases, or partially contained databases. That's how they call it properly. And Windows Server Core. And then we're going to have a couple of slides at the end on the things that you should do and things that you should avoid. Now let's move right into it. The SA account. Well, the SA account is an omnipotent account. It's the administrator account. It's the sysadmin level account in SQL Server that has permissions to do everything and anything. What things that you should do about it, number one, you could just rename it. Number two, you could disable it, or you could rename it and disable it, or you could not ever use it, or you could forget that it even exists. Here I'm going to propose something that's quite useful for a whole bunch of you. There seems to be a breed of SQL Server software vendors out there that rely on SA permissions for their applications to work correctly. I am not particularly fond of these vendors, so I have this idea that I want to propose to you guys. This is something that I have actually done to some of those vendors in the past. I am going to show you how to do an SA honeypot. And I call it SA honeypot because it really has two uses. You could use it to you could use it to disguise the actual SA account, and the other use is to actually figure out who's trying to log on to your database server as SA. So I'm going to go ahead and show you here on my SQL Server instance that I have. This is a SQL Server 2012, and I'm going to run zoom it because I had it launched, but now I have it launched. So I want to show you guys that I'm running SQL Server 2014 here. And I don't have any more logins than the ones that are built in, and maybe one Windows account here, but nothing else. And so SA is the actual SA user that comes with SQL Server. Well, like I said before, one of the things that you can do about this login is that you can actually rename it. So I can just right-click on, let's say, rename, and I can set this to whatever I want. In this case, I am going to change it to correct battery horse staple. And that is a reference to an XKDC cartoon. If you guys haven't watched that one, definitely highly recommend that you read it. And then the other thing that I'm going to do now is that I'm going to create a new login that's called SA, and I'm going to set this one to whatever strong password, P at @ssword99 exclamation, which is fairly well-known password for us, so I'm not going to enforce a password policy. This is just for demo sakes, so please bear with me. And now I have created a new SA password, an SA login that has no privileges whatsoever on the instance. So this is fantastic because what I can do is, if I have a test database, for example, like I do here, have a test database. Now I can actually grant say the test database is for my test application, so I'm going to rename it to my test app DB. Now I can grant that as a user. I can grant permissions to that test app DB with whatever permissions the vendor. I believe I just had audio issues. Can you guys hear me okay? Jody?
Yeah, there's a big background noise. That's gone now. Argenis, are you there?
You guys hear me now?
Yeah, we can hear you. Yeah.
You can hear me?
Yes, we can hear you.
All right, so I just experienced an audio problem, so I apologize for that. Anyway, I'm not sure exactly when the audio went off, but I'm going to quickly try to recap what I was showing here on the screen.
Yeah, so if you can start from where you renamed the SA account.
Okay, all right, so I'll do that.
So yeah,
so basically I was showing you it. Okay, I'll start from there. So basically, I just renamed the SA account, right? And the idea behind this is that I can go ahead and create another login, which I just did here, called SA, and that user doesn't have to have, and that login doesn't have to have any particular privileges on that are instance-wide, but they can be granted privileges to a particular application database. Like for example, in this case, this test app DB that I have on my system. Now I just granted DB owner permissions to that doesn't have to be DB owner, can be more granular. This is just for demo's sake. Now imagine the case, and I understand and totally understand that this is controversial. The other situation that you might be facing is that the installer for the application that you're trying to support checks whether the SA user not only exists, and you can leverage that one, but that it's also part of the sysadmin server role. Well, you can actually make this user member of the sysadmin role as well, as I'm showing you here on the screen. Essentially, by choosing the sysadmin server-wide security privilege, you grant it to that user while the installer runs, and when the installer is done installing, you can go right back and take that permission away, or that level of permissions away from that particular login. And thus, your application will continue to run on the user that's called SA, but it will no longer have SA permissions. Now, as I said before on the slides, I call this SA honeypot because it also has another benefit, or you could use it separately and with a different benefit, which would be try to figure out who's testing your instances out there. If there is anybody that is attempting to connect to your SQL servers using an SA login. So if you rename the actual SA login, you know for sure that person will never, even if they had a previous password, you understand what their actual password is, they will never be able to log on or if they do log on, they will never be able to do anything on the instance. Let's talk a little bit about something different. We're going to change our gears a little bit here. We're going to speak about database and application firewalls. Database firewalls essentially work at the network layer. They are devices that sit between your application servers and your SQL servers. And these devices essentially, sometimes they work just connected to a switch on a mirror port, And basically what they do is that they analyze every single piece of traffic that comes to your SQL Server, or every single query that's about to hit your SQL Server, and scan it for particular patterns. So in the event that somebody's trying to perform a SQL injection attack against you, the database firewall, the application firewall, will effectively prevent the attack by capturing that malicious query from, preventing that query from ever hitting the database. So they can be really effective. Some of them are also known as web application firewalls. Some don't necessarily work at the database layer by analyzing the TDS or tabular data stream connections from the client to SQL Server. Some just sit at the web server layer, and they analyze every single URL that's being hit, or every single parameter that's being passed to the web server or application server. Like I said before, this can definitely prevent injection attacks at the application layer. And they can also inspect every TDS packets sent to the server. And they can also, and this is actually very interesting, they can work alongside agents to further secure access to the database. So if you have a set of rules that can be pushed to your SQL servers, some of these database and application firewalls, the agents are set on the network connections on your SQL servers. These are actually installed on the servers, so they do work on top of Windows. They analyze every single packet that's hitting your SQL server. So they can actually prevent internal attacks. So somebody's logging in locally, they would have to go through the network, and even through the loopback interface, as long as you don't have things like shared memory enabled. These will prevent internal attacks as well. And then essentially they will perform the same task as the firewall, as the hardware firewall appliance, and they can prevent any malicious or non-conforming to a given pattern query from ever hitting the database. Let's talk a little bit about our database, about Active Directory security. Why is Active Directory relevant to us as DBAs? We should actually leverage AD groups whenever possible. I am not really fond of creating logins on SQL Server that belong to specific users. I rather create roles. So I create a group, an AD group for a particular role. Say I have a reporting group, and then I include members of particular logins into that group. I can add them on ID in that group, and that way they are automatically granted permissions to do, say for example, reads on the database via this reporting group that will be granted data reader permissions, for example, or select permissions on given tables. The other thing that's very interesting about Active Directory is that you can actually leverage GPOs, which are group policy objects, to enforce strength and password expiration on accounts. So if your account you have created a particular login in SQL Server as conforming to your password policy or your password strength policy, then or expiration policy for that matter, then the GPO can validate that every single login is conforming to that policy. And if it's a weak password, it will not allow that account to be created. Or if the password hasn't been changed in so long, the password for that account will be, that account will automatically be disabled until the password for it has been changed. Now this is particularly useful for service accounts, because you can actually enforce strength and password expiration on those as well. Be careful though, because once your service account's password expires, your SQL Server will no longer run, which is a big problem for you. So be extremely careful. What you can do in advance is report, create some sort of report from AD. There's actually code for this out there that checks, when an account is about and how many days that the account has to go before you actually have to change its password. This is very important. During my time as a consultant, I found this to be a huge security problem out there. You should isolate your development test, QA, staging, and production environments on their individual OUs, or even better, to set them on different domains or completely different AD forests altogether. Try to isolate these environments as much as you possibly can. Why? There tends to be a lot of reuse of accounts across environments on companies out there, and it's a big problem. If your QA, say for example a QA server, has the same service account as your production server, and your QA SQL Server can talk to your production server, that means that you can run anything you want in production if you have access to QA. Because what you really have to do is you run enable XP Commensal on your QA instance, and then run SQL CMD under XP Commensal, and now you can hit prod using the QA service account, which is because you set it that way, it's not the exact same account. So that's a big problem. How do you get away from that? Well, first of all, by not using the same service account on different SQL servers, but furthermore, you should really separate QA and production on different subnets and different domains of force on AD, if at all possible. Now I'm going to talk a little bit about IPSec. IPSec is a technology that essentially does encryption of IP packets on your network. And this is great when you get that requirement from management to encrypt data on the fly. When they tell you, oh, well, we should use certificates and all of this stuff to encrypt data from the application server to the SQL Server, well, it's not really necessary. That's not necessarily the best way. IPSec works great on domain environments. Now, granted, if you're not in a domain, on an AD domain, you might want to look at something else. But for domain environments, IPSec is just a slam dunk. It's a policy that you actually enable on your Active Directory. So you can specify exactly which hosts are going to be IPSec enabled. If you don't know how this works, just get in touch with your AD person or get in touch with your security guy at your company, and they can tell you how this works and how you can enable it and further secure your network. Like I said, it provides network level encryption, and it can be restricted to a set of hosts, which is particularly interesting because you don't have to encrypt communications to every single server out there. You could force IPSec on a particular number of servers that have very sensitive information while not having to force encryption to anything else. Obviously, the more encryption you use in your network, the more secure you're going to be. Now, this is easier to set up, like I said before, than an application or web encryption at the application or the web level, because you're not going to have to deal with things like SSL certificates and things of that nature. The good thing about IPSec when it's rolled out through Active Directory is that whenever a host joins and it falls under the policy that's managing the particular OU where that host is sitting, that host is going to be automatically protected, meaning that its communications are automatically going to be encrypted. Now, switching gears, I'm going to talk about a different technology that you can also leverage to further secure your instance. Transparent Data Encryption, or TDE. This is great for when you get that requirement of encrypting data at rest. It provides a storage level encryption, and this means that nothing in your instance really gets encrypted, but everything is encrypted as it's written to disk, which is really important. It's managed on a per instance basis. So if you have multiple instances on a box, you can say instance A is actually leveraging TDE for a particular database, or an instance B can remain unencrypted. But these can have a significant impact, performance impact, because every single block needs to be encrypted before it hits disk, which can have definitely a big performance impact. There are some widely varying numbers on how big this performance hit is. You know, people will say 5%, others say 15%. I have used it a couple times, and I have seen around the 10% to 15% decrease in performance by using TDE. On some other instances with much better I/O subsystems and higher amount of resources, I haven't seen such a big impact in performance. The one thing I wanted to mention about TDE is that once you enable it in one database,
Argenis will have audio again. Okay, just hold on, guys. We're working on the problem.
It looks like I was having audio issues again. Can you guys hear me now?
Yeah, we can hear you now.
Okay,
Could
where
you
did I
just
go?
okay, can you repeat back from performance?
Okay, so basically I was mentioning the performance impact that TDE can have on an instance. It definitely have a significant performance impact because every single block that's going to be written to disk, it's got to be encrypted before it hits disk. So that has significant overhead. Now there are widely varying numbers on how big that performance hit is. They vary from 5% to 15%. What I've seen out there in the instances that I've worked on that have TDE enabled is around the 10%, 10 to 15%. One thing that you should consider and definitely keep in mind when you're working with TDE is that TDE, if you have an instance that say has 50 databases, even if you encrypt one of them, 10 dB on the instance gets encrypted. So every single database is going to be suffering from the fact that you enable TDE from one particular database. The reason for this is that you could have a query from that one encrypted database that spills to disk. And if that query does spill to disk, it means that it's going to have pages created on TempDB. And to comply with the data encryption requirement, those pages will have to be encrypted as well. TDE not only encrypts your data file, but it also encrypts your log file, your transaction log file, which could have a significant impact on performance, like I said before. I'm going to move on and talk about the next feature that could help you secure your instance further, and that is SQL audit. You should, at the very least, audit DDL, because you really want to understand if something changes on your server, who did it and why. You should keep a close track of what operations are placed on your server at all times. You might be forced to audit for compliance. If you can't really prevent something from happening with auditing, at least you'll know when it happens and who caused it and how that exactly happens. Now, auditing is particularly great for leaving a forensic trail. So, like I said before, if something does happen, you have that information readily available for you. Also, you need to keep in mind that transaction log is a gold mine. Every single thing that happens on SQL Server is actually logged on the transaction log. So you can definitely browse your transaction log manually by leveraging functions like FNDB log, or you could use a third-party application for browsing the transaction log. There's plenty of those out there. You might feel free to search for them. So if you don't know what happens, you can always go back to the transaction log. And you can even look at the portion of the transaction log that has been cleared as long as it hasn't been overwritten on disk. It's also important to remember that we still have the default trace available. Default trace is a feature that came with SQL Server 2005. It's a trace that's always running on behind the scenes on every single SQL Server, and it sits on the same folder as your error log file. You can browse that file. You know, whenever there's big changes, major database, it's not as extensive or as configurable as SQL audit. Of course, you have to disable the default trace. You cannot change the default trace. You can disable it and roll your own. But if you have Enterprise Edition and you have the capability of using SQL audit, I highly recommend you look into that because it's actually extended events based. And so the overhead of running a SQL audit is much lower than running a profiler trace. Now, with that said, extended events are available on every single version of SQL Server. So if you don't have Enterprise Edition, but you do have, say, a Standard Edition, you can leverage extended events to roll your own audit. Now, you obviously have to do a whole bunch of coding to mimic the functionality that SQL Audit offers, but you can definitely do this. That's what I was just talking about now, the default trace, and just forgot to move my pointer here in the presentation. So
You have to remember that the default trace is in deprecation path, so it might not be present, still present on SQL Server 2014, but it might go away very soon, so keep that in mind. Something that's also important, you might want to audit successful logins. Why? Because when you know that a successful login took place, you might also want to know where that login came from. It's not just the fact that it was he or she was able to log in, but where did that login take place? So if that login came from an unauthorized client, that is something that you should definitely follow up on. If you see an IP address that you had never seen before, you only have a subset of application servers that are supposed to log into your SQL Server, and all of a sudden you see a strange IP address sitting in there, that's something that you want to follow up on. So now let me talk a little bit about contained databases. Now, contained databases, the concept is very simple. The logins are actually contained in the database and not kept in master as server principals. Standard logins and users can be made contained. So if you have an application that leverages regular logins today, you can actually enable contained database users on your instance first. You have to enable it at the instance level first, and then you have to enable it on the particular database that you want to work with. But you can take an existing login or existing user and they can be made contained. And you definitely want to use this feature if you're leveraging all of these HA or VR features like always-on availability groups or database mirroring or even log shipping with standby secondaries. The reason why you want to use this is because you actually don't have to create the logins and the secondaries anymore. If you have a contained database user, the moment that database becomes readable or online, that login can be, that contained database user is ready to go. You know, that the creation of the actual contained database user is actually replicated to the other instances. Now be careful here, there are gotchas when you enable contained database users. Things that read from the transaction log actually break when you're using contained database users, things like CDC and change tracking. There are a few gotchas when using contained database users. These things might change in the future, but they haven't really been fixed yet. Now, another feature that I wanted to mention, and I have a much larger presentation on Windows Server Core that's available at sqlbits.com. Windows Server Core is basically a stripped-down version of Windows, but it's not really stripped down. It offers the same functionality of Windows with a reduced surface area. What I mean by this is that you're not installing every single feature of Windows that you actually need. In particular, the graphical interface. You don't really need the graphical interface on a SQL Server. You could have a jump box that has all your administration tools to manage it from and manage a box from there. Now that reduced surface area, it's a fantastic security improvement because now you only have as many attack vectors possibly exposed out there to your network because you're not running all those bits that could have potentially have issues. That also means that there's a lot less patching because now you have a lot less software to worry about and patch. So now your patches are going to take way less than they used to. There's a lot less of let me log into the server and just launch Internet Explorer and start browsing the internet from the production server, which unfortunately is something that I see being done very frequently out there. Even us DBA sometimes get lazy and just launch IE and start downloading patches from the internet. It's just a bad idea. Do it elsewhere. Protect your server as much as you possibly can. Right, so now we got to move on to the things that you should do. And there's going to be a couple of slides on this. First of all, you should sanitize all your inputs, and you should do it twice if you must. And this is something that obviously involves touching code. So I'm kind of moving a little bit away from the things that are codeless and moving on to the things that you should speak to your developers about. First of all, whenever you get a code whenever you want to perform a code review, ask your developers if they're sanitizing the input. It's just a friendly reminder. Did you do this? Did you forget by any chance? Just make sure. It's a good double check. if you must, you should do it in both places. You should do it on the application layer and then on the SQL layer. Just make sure that whatever parameter was passed to you is valid. Lock your workstation. I don't know how many times I have seen your locked workstations out there, even those belonging to DBAs at high-profile companies out there. You know, if your security team hasn't already rolled out a locked workstation policy on your network, please talk to them about doing so. Imagine what could happen if you all of a sudden feel the urge to go and your workstation remains unlocked. Well, somebody malicious. I mean, it doesn't even have to be, you know, a hacker that works in your company. It can be anybody really. Imagine a visitor is just passing by and now he sees your cube with your workstation unlocked, and you have full privileges to your database server. Well, that is a huge problem for you. How are you going to prove that it wasn't you who did something? So log your workstation. Oh, lock your workstation is very easy. Just hit the Windows key and hit L. Don't do it now because that's going to close your GoToMeeting session. Windows plus L, that locks your workstation right away. You don't have to do much. You don't have to do Control-Alt-Delete and then go through all these menus anymore. Scan your network periodically for new SQL Server instances. This is something that's fairly common out there. People just come up with new applications, and now all of a sudden the SQL servers are running on a desktop under their desk, and well, you have no control over that SQL server, and all of a sudden it becomes really important for the company. Well, it could also pose a big problem in terms of security. So scan your network periodically. There's tools to do this. There's a SQL ping. There's an assessment tool. From Microsoft that allows you to do search for SQL Server instances out there. There's a myriad of these tools that you can leverage. You should definitely hire a professional to do a penetration test that includes social engineering attacks. And actually, I want to remind you guys that the people are your biggest problem in terms of security. So if somebody is not very security aware and has high profile access to your database, that's potentially a big problem. So if you hire a professional to perform a penetration test against your network and starts doing things like dropping USB drives on the hallways with malware that automatically tries to connect to databases and things like that, or at least raises a flag when it does so, you know, that's a good professional to have. And these things are actually very humbling. You know, when you get the results from a penetration test, they tell you what's wrong with your network. And you know, no network is perfect, and no security setup is perfect, and people are definitely imperfect. So if this professional performs social engineering attacks, then you know you can leverage what your you can actually understand what your biggest weaknesses is on your enterprise. This is hugely important. Educate your developers and vendors. When you get a vendor that tells you they need SA privileges, just try to push back as much as you possibly can. If they don't understand why you're pushing back so hard, you should teach them why. You should try to educate them. Why is using SA a bad thing? You should leverage the principle of least privilege. So educate your developers and your vendors. More things that you should do. Let's look at another slide here on more things. You should definitely enforce the principle of least privilege. And this is what I was just mentioning to you guys. Principle of least privilege means just grant very finely granular permissions for what you need. So if you get a requirement for somebody to read from a table and you don't have a store procedure to read from such table, don't just go grant data reader to that person in that database. Grant individual permissions like select on that particular table, and that's it. And don't grant anything more than they actually need. Keep the privileges very granular and very minimal, and that goes to great lengths to enforcing security. There's obviously more administration and more overhead involved in doing this, but like I said at the beginning, security is hard and it's hardly convenient. Reduce your exposure or your surface area. So turn off the things that you don't need. For example, if you're not using reporting services on an instance, why have it enabled at all? Just uninstall it if you can. Turn off disable the services if you're not using it. Reduce your exposure as much as possibly can. Lockdown production. I don't know how many times I have seen production SQL servers that are sitting on the same corporate network as the rest of the resources in an enterprise. That might be a good idea at times, but most of the times it's a really bad idea. So put production on its own AD domain, put production in a separate subnet, firewall it, lock it down, try to prevent exposure of your production assets to your external or corporate network. That doesn't make much sense. Things to avoid, and again, we're talking about the things that are not necessarily, don't touch the code here. SQL servers hitting on boxes with internet routable IP addresses. Look, guys, if you enable, if you put your SQL server on the DMZ or out on the internet, it's going to get attacked. It's going to get scanned periodically, and when a vulnerability for SQL Server pops up, your box is going to be attacked. You can bet on that. There's tons of people, very malicious people, that are constantly scanning the internet for new boxes sitting out there with vulnerabilities. And you don't want to be that guy. You don't want to, be that enterprise that got hacked because a SQL Server was sitting with a routable IP address, so exposing port 1433 out to the internet. Exponential. Exponential is a terrible thing. Unfortunately, a lot of enterprises require it. A lot of applications still require it. It's just a bad practice to enable exponential. Why? Because exponential by default runs with the privileges of the SQL Server service account, which means that if you run it, if you grant permissions to anybody to run exponential, all they really have to do to get any access to any database, to any information sitting on the instance, is just run exponential and run SQL CMD inside of it. Really. Don't do that. It doesn't make any sense to enable exponential if you don't need it. Trustworthy. I see tons and tons and tons of people advising others that to fix CLR problems, you must enable trustworthy. Basically, trustworthy means if you have this level of access to my database, now you have that same level of access to all the other databases. Well, that's just a bad security practice. You do not need trustworthy to enable CLR, or to make it work for that matter. Do not ever use the same service account or password across development, test, QA, and prod. Use separate service accounts with strong passwords on every single environment. This is a big problem, like I said before. Imagine if you're using the same service account and password on QA and production. Now somebody who's running something on QA is perfectly able to run something on production because they're running under the same service account. You can generate credentials on QA now to log onto their production instance. Huge security hole. Silly things, and this is something that I have, that's a pet peeve of mine. Using non-standard port numbers, I don't think this is a good idea anymore. Look, guys. It's 2014. Security by obscurity, it doesn't help that much anymore. Right? Tighten access and audit instead. Imagine if you're running SQL Server on port 5431, it's just going to be a little bit harder for somebody who's trying to hack into your instance to figure out which port SQL Server is actually running under. It's probably going to take them, I don't know, about 5 more minutes, maybe less than that, to figure it out. But instead, changing that non-standard port number costs a huge nightmare on your network policies and your security policies throughout your environment, because now the ACLs for accessing SQL Server have to be very particular about specifying that particular port where that particular SQL Server is running. Now, is that a good idea? Is that worth the effort? If somebody trying to scan your network can figure that out in a few minutes? I don't think so. So instead, what I recommend is that you tighten access and audit instead. And when the audit stops running, and this is very important, something that I really want you to take away, when an audit stops running, that should be a huge red flag. Alerts should be flying off of your SQL Server when audit stops running. And you should look at that immediately, treat it as a very severe incident. I'm also going to recommend that you get this book. It's called Securing SQL Server, Protecting Your Database from Attackers. It's by Danny Cherry, a good friend of mine. This is highly recommended. You gotta go ahead and get it. Now, I think we're ready to move on to the Q&A. Jody, do we have any questions sitting on the queue?
I had a few.
Jody?
One is around, just unmute. Sorry, my mic wasn't mute. We had a few. One is around, is it safer to enable XP command shell as needed and disable after such processes are completed?
So enabling XP command shell, like I said before, it's a bad idea. If you must enable it, do something really quickly and turn it off. That's not as bad as enabling it and leaving it enabled. However, I will remind you that most of the time we enable these things, we do something, and then we forget to turn it off. And that's the bigger problem. So I would rather leverage other facilities to do whatever it is that we need to do without using XP command shell. Like for example, you can definitely still run command exec type of jobs or job steps on SQL Server agents. So instead of doing something with XP command shell, I will leverage that command exec job step, and I will keep that job disabled with no schedule, so I know that it's never going to be run. So that's a much better idea than just enabling XP command shell and leaving it, risking the fact that it might be left enabled. Is there any other question?
Yeah, we have a few. One, any general recommendations for securing Azure House SQL solutions?
So Azure Database is very different than SQL Server on its own. You have very limited capabilities of securing your Azure instance. Now you can definitely impose all sorts of firewall rules on it, so only certain IPs can hit it. That's definitely recommended, and you should do that. And obviously lock it down as much as you possibly can. There's not a whole lot that you can do about Azure though. Just track and log as much as you possibly can.
Okay, then we have, what about third-party products? Like
I'm sorry, Jody,
or...
when it comes, I'm going to go back to the previous question. That question might also apply to Azure VMs, and I'm sorry I interrupted you, Jody. That question may also apply to Azure VMs, or Platform as a Service. If that's the case, then we're talking about securing just instances of SQL Server that are out on the cloud. They're full-blown SQL Server instances. All the concepts that we talked about today apply to those kinds of VMs, so you can definitely leverage them.
Cool. And then what about third-party tools like Netrix or AppSync products?
I'm not necessarily familiar with them. I'm not familiar with those products that you just mentioned, Jody, but if the person who's asking the question can send me an email, my contact information is going to come up on the next slide, so I'll be happy to respond to any concerns or any questions about that particular product.
And then on clustered instances, does the engine AD account need to have sysadmin? No.
I'm sorry, say that again, Jody?
On clustered instances, does the engine AD account need to have sysadmin rights?
So the engine AD account, I think you're asking about the SQL Server Service account. The SQL Server Service account, even on clustered instances, has to have sysadmin privileges on the instance at all times. There's just no way around that. If you're talking about any other account that's not the SQL Server Service account, let me know. But I don't know exactly what you talk about, what you mean by engine account. If that's it, the SQL Server Service account, then yeah, it definitely has to have sysadmin privileges.
Then we have a question here from Garrett. Any security auditing or monitoring software you would recommend?
So I'm not at liberty to recommend any particular security software here. The best thing that I could do for you is if you shoot me an email separately and you have any particular requirements, I might be able to point you in the right direction. but at this point I cannot make any public statements about recommending any particular security third-party software.
Okay, then we have a question from Chris Testa O'Neill. As well as the audit you mentioned in SQL Server, would you recommend enabling NTFS auditing on key SQL folder locations?
So NTFS auditing, yes. And so NTFS auditing can definitely help at times if the people who you're concerned about have the people have access to the server. You have concern about these folks logging into, getting into the SQL Server folders and performing copies of your database files. So that's a great point that's been brought by Chris. If you have concerns about your sysadmins just perusing your database files and copying them and restoring them elsewhere or attaching them elsewhere and reading from and sensitive information from those, you should enable NTFS auditing. Now, be careful on which features of NTFS auditing you enable, because the amount of information that might be generated by NTFS logging can be overwhelming, and it can actually go in detriment of the performance on your instance. So that's a great point. Thank you, Chris.
Okay, where can we get more information about setting up IPSec?
Where can you find more information about IPSec? Well, I pointed you guys to that book, and I don't know if I was allowed to make a recommendation of that book. That book speaks a little bit about IPSec. Or if you just go to your favorite search engine and type IPSec site:/Microsoft.com, you will find tons of information on how to enable IPSec on your networks. By the way, IPSec is free. It doesn't cost anything. It comes with Windows. So if you are in a domain environment, you already have IPSec.
Okay, then we have one here from Gustavo. Is it less dangerous to use XP command shell with a proxy account with low privileges using command shell proxy account?
So the problem with using XP command shell with proxy accounts is that you can forget about setting up the proxy account. And then how do you know that's the case? And if you're not alerting and reporting on these things, then it becomes a security problem, doesn't it? It's like I said before, there's a feature that is really sensitive and it can be a cause for a lot of trouble, I'd rather not enable it at all and leverage other facilities to do whatever it is. That tip that I gave before about using command exec jobs, it's usually a much better idea than enabling XP command shell, even with proxy account.
Okay, then we have, still more. Okay, we'll just go through this. Okay, with a question around the clustering, people are asking, are you saying that the SQL Service account needs sysadmin at all times?
Yes, the SQL Server service account, there's no way around it. The SQL Server service account needs full-on sysadmin privileges at all times. There's no way around that.
And okay, here wants to know, could you show your database application slide again? Also, what about, Mike Walsh wants to know, what about encrypting SQL Server backups?
Okay, so I'm going to tackle the last question first, the one about backups, and then you remind me of the other one. For backups, whenever you execute a backup, depending on where you save the backups, then you're going to access that network path. If it's a local, I take backups locally first, and then I copy them off to the network because I can afford to do so. I understand a lot of you out there are actually using UNC paths for your backups and saving them to the network. Whatever service account you're leveraging for SQL Server, if it's a domain account, that's going to be the account that hits your your share. So you have to grant permissions to that particular account. If you're not using a domain account for SQL Server, you have to grant permissions to the computer account. So that's the one that's going to write the backups to that location. Now, some people are actually a little paranoid in this regard and grant the SQL Server service account permissions to write to that folder, but not to read. So they don't even trust that people will have the permissions on the or know the password to a SQL Server service account to read from that folder. So that's we're getting into a dedicated arena, and if you have any concerns in that regard, you can send me an email. I'll be glad to follow up on that. By the way, my contact information is here on the screen for you guys. If you have any further questions, you can tweet to me at Argenis. You can look at my blog. I have a couple of interesting security blog posts. You can feel free to shoot me an email whenever you like at argenis@gmail.com. We do have, and this is a perfect time for a plug, we have the security virtual chapter for PASS. And I also wanted to make a quick plug here for the SQL help hashtag on Twitter. If you have any questions, you can get access to very high-end, high-profile consultants or even Microsoft employees on Twitter. And just people are generally very helpful just by tweeting with the SQL help hashtag. Are there any further questions at this point?
Yeah, there's one around how do you secure the SQL agent, and what is the alternative to the XP command shell?
Say that again, sorry?
What was the alternative to enabling XP command shell?
So the alternative to enabling XP command shell is to leverage the SQL Server job. A SQL Server job, you can create a job stack, a job step that is of the type command exec, and that would actually execute just like an XP command shell. It's just that it will run under the privileges of the SQL Server agent account, but you can create a proxy for that, and you can limit access to that job by you can have it so that it doesn't have a schedule and it's disabled at all times, and you can actually audit, whenever that job is run and etc. So if it's a very specific operation, it can be run that way. Or you can leverage CLR, which is a much better option. Obviously, there's some coding involved, and I understand it's not as friendly as just running a job for executing file system or other types of operating system level operations.
Okay, then last question, because we have to end as the next session is about to start. Why does SQL Servers why does the SQL Service account require sysadmin?
Why is the SQL Server service account by default a sysadmin? Well, because it needs to be able to perform. Yeah, because that account needs to have full-on privileges to do anything on SQL Server. That's the bottom line.
Cool. So, yeah. So
right.
we have to wrap up now. Our next session is about to start. Thank you, everybody.